Alright, and welcome to our video, All Things Absolute Value. Now this is going to be a long video because I'm going to cover every problem on the page. Once again, find the ones that you don't know, click through the video until you can find those problems, and then those are the ones that you should really focus on. Let's go ahead and start with number 1. It says a function f of x equals the absolute value of x is changed to become g of x equals 5 parentheses x minus 5 minus 100. Well, let's take a look at each part of this. Here, let's use this orange color. I see that my a value, a equals 5, and so I know that since a is greater than 1, it was vertically stretched. Alright? Here, I see inside the parentheses, I see this x minus 5. Remember, I'll set that equal to 0. Can add 5 to both sides. And x is equal to 5. So what does that tell me? It tells me that we were translated 5 units. It's positive 5, so 5 units right. Lastly, this minus 100 is on the outside, so this tells us that we were translated down 100 units. Pause the video, finish taking any notes. Let's move on to example number 2. Okay, for example number 2, we want to find the domain and range of the function below. Well, notice here that this is an absolute value function. Okay, I notice that inside my grouping I have x plus 5. I can set that equal to 0, and x will equal negative 5. So this tells me that my vertex is at negative 5, comma 12. So I can even graph this very quickly. Go to the left 5, I can go up 12, and I know that since my a value, since a equals negative 3, this graph reflects down. Okay, and now that we see the graph is pretty simple. What is the domain? Well, it extends to the left to negative infinity. It extends to the right to positive infinity. So our domain is all real numbers. And remember, you can also write that using the all real number symbol, or you could even say it is from negative infinity to positive infinity. All three of those will work. Now let's talk about the range. The range is usually a little bit trickier. We write y such that y, and we're really saying, well, you know, our k value is 12. Is 12 the highest value or the lowest? And since 12 is the highest value or the maximum, we're really saying that y is everything below that. And the way we say below 12 is less than or equal to 12. Alright, pause the video, finish taking notes. Let's move on to example number 3. Okay, number 3 says this. It's a very long, wordy problem. Major League Soccer rules state that soccer balls are to be inflated to 13 psi. Prior to each game, the referees check the 3 game balls. If the game balls are inflated to 1 psi more or less of the desired weight, they are approved for use in the game. Which absolute value equation represents the least and most the soccer ball can weigh? Well, you need to have this formula. This is the actual, so this is x, minus the ideal is equal to the range. Well, you're always going to have x minus our ideal is 13 is equal to our range of 1. And here the answer is very clearly going to be B. Oh, B, correct. Cool. Alright, pause the video, finish taking notes. Let's move on to example number 2. Okay, for problem number 4, it says find the value of y, but you know what? I use the letter m here, so let's scribble out y and let's put letter m. That makes the equation shown below true. Well, remember, anytime you have your absolute value bars, you always want to take what's on the right and set it equal to the positive or negative version. So this means that we can write 2m plus 12 is equal to a positive 7m minus 3, and 2m plus 12 is equal to a negative 7m minus 3. Now from here, when you multiply by a positive 1, you really don't change anything. So I can write 2m, I don't know why I wrote 3, 2m plus 12 is equal to 7m minus 3. And when I solve for m, of course, I'm going to move the smaller m first. Minus 2m, minus 2m, and I have 12 equals 7m minus 2m is 5m minus 3. I can add 3 to both sides, plus 3 plus 3. 12 plus 3 is 15 is equal to 5. Oh, I wrote x instead of m, 5m. And now I can divide both sides by 5. And of course, m is equal to 3. Now, let's go ahead and test out the other side. I have my -1, and I'll distribute that. So I have 2m plus 12 is equal to -1 times 7 is -7m, and a negative times negative is a positive. Once again, what do I move first, my variables or my constants? And hopefully you said our variables. So we can add 7m to both sides, and 2m plus 7m is 9m plus 12 is equal to 3. From here, of course, we can subtract 12 from both sides, and 9m is equal to -9. I divide both sides by 9, and m is equal to -1. Now, a lot of y'all stop here, but that is a huge, huge, huge mistake. You need to figure out if these are both solutions, if one of them is a solution, or if none of them are solutions. Pause the video and finish taking notes, and I'm going to clean this up just a little bit. Okay, so here we know that m equals 3 and m equals -1. But how do I test this out? I'll do it like this. I'll say the absolute value of 2m plus 12 is equal to 7 times 3 minus 3. Okay, so the absolute value of 2m plus 12 is equal to 7 times 3 is 21 minus 3, and 21 minus 3 is 18. So I have the absolute value of 2m plus 12 equals 18. Well, check it out. Since 18 is positive, this is probably a solution. It is probably a solution. So we would say m equals 3 is good. Now let's check out the other side. We could really say the absolute value of whatever is inside there is equal to 7 times -1 minus 3. So remember, I'm pulling that from that 7m minus 3. Then we have the absolute value of whatever is equal to 7 times -1, -7 minus 3. And the absolute value of whatever is equal to -10. So what are we really saying? We're saying the absolute value of 2m plus 12 is equal to -10. Remember, your absolute value bars can never equal -10. This is not a solution. Our only solution is that m equals 3. Finish taking notes. Let's move on to example number 5. Okay, for number 5, it says find the solutions to the inequality below. Well, notice you always want to get your absolute value bars by themselves. So the first thing we want to do is get rid of our addition, -6 minus 6. I now have -3, absolute value 8 minus 2x is greater than or equal to -30. At this point, I'll divide both sides by -3, divide by -3. I get the absolute value of 8 minus 2x is, wait a second, we just divided by a negative. What happens to our inequality? Well, it flips, and our greater than or equal to symbol becomes a less than or equal to. -30 divided by -3 is 10. Now remember, for absolute value, you have to memorize what are these symbols, and this is our less than symbol, less than, which really is our and statement. It is our and statement. So I changed my +10 to a -10, less than or equal to 8 minus 2x is less than or equal to 10, and from here I just solve for x. Here I minus 8 from every single place that I can, -8, -8, -8, and I get this. I get right here, -18 is less than or equal to, -2x is less than or equal to 2, which I'm going to write right up here. If I could write the -2x correctly, that would be nice. -2x, all is less than or equal to +2. Now this one's going to be a little bit tricky because we'll divide both sides, or all three sides, by -2. Well, what happens to our inequalities? They all flip. -18 divided by -2 is +9 is greater than or equal to x. This flips to be greater than or equal to 2 divided by -2 is -1. Now this is okay as an answer, but it's not how you'll see your answer choices. Everything here has to flip again, because we always want our smallest number on the left, and -1 is less than or equal to x is less than or equal to +9. Here is our true final answer. All right, 2 more. Let's move on to example number 6. Okay, for example number 6, it appears that we actually have something very similar. Okay, so we know we want to start by subtracting 6 from both sides, and I have two absolute value, 8 minus 2x is greater than 18 minus 6 is 12. From here, of course, I want to divide both sides by 2, and I get the absolute value of 8 minus 2x is greater than 12 divided by 2 is 6. Now from here, remember, when you have a greater than symbol, greater than, well, this is really our or statement. Okay, so I actually have to split this up into 2 different segments. 8 minus 2x is greater than 6, or 8 minus 2x is less than -6. Notice that when this goes from a positive to a negative, that's when the inequality flips. Well, from here I can subtract both sides by 8, and I get -2x is greater than 6 minus 8 is -2. I can divide both sides by -2, and notice because I divide by a negative, my inequality flips, and I have x is less than +1. Or, now let me go ahead and actually rewrite this one just right here. So we have our 8 minus 2x is less than -6. Well, we subtract 8 from both sides, zeros out. -2x is less than -14. I divide both sides by -2. And remember, when I divide by a negative, my inequality has to flip to be greater than +7. All right? And this is our final answer. X is less than 1, or x is greater than 7. Let's go on to our final example. And it's relatively short, so I would encourage you to watch it. Okay, it says, which equation is used to find the solutions to -1/4 absolute value 2x minus 6 is equal to 2x minus 5. Well, notice that here our absolute value bars are not by themselves. So how do you get rid of this -1/4? You multiply by -4/1. You multiply by the reciprocal. Over here, we'll multiply by -4/1. But remember, -4/1 is just -4. So this is what happens. The -4/1 times -1/4, they cancel. And I'm left with this. The absolute value of 2x minus 6 is equal to -4 times 2x is -8x. And -4 times -5 is +20. Now at this point, y'all know exactly what to do. We take away our absolute value bars and make the right-hand side positive or negative. So I can write this, 2x minus 6 is equal to -8x plus 20, because when I multiply by +1, it doesn't change anything. Or I can write I can write 2x minus 6 is equal to, a negative times a negative is a +8x, and a negative times a positive is a -20. And this problem, the reason that I didn't write these side by side is because this problem isn't asking me to solve. It's asking me which one of these answer choices is an equation used to find our answer. So let's see, we have 2x minus 6 is equal to 8x plus 20. Well, that's negative and positive, that's positive and negative, so it can't be that. But here I have 8x minus 20, aha. And it's this equation is the same as letter D. Alright? I hope that this video was helpful, and I'll see y'all in our next video series.